wise men once said that procrastination is the mother of aggravation. We're going to be working on a Revox A77 tape deck. This beautiful piece has lived in Studio 7 for quite a while. One of the first things he said to me was that, you know, these capacitors are notorious. And I thought, well, we'll run it until it needs help, because if it ain't broke, don't fix it. That's my argument. Well, playing a tape on it the other day, tape finished, everything was fine. I, about 10 minutes later, walk into the studio, and this is what I was exposed to. And yes, I am risking making the situation worse by powering this up without having even unbuttoned it yet, but I'm hoping it won't cause more of a problem, but I want you to hear what's going on. Right here on the VU meters, you watch what happens. They're pinned. So it just went, I mean, right off the top. When you've got severe hum like that, you best not actually try to operate that device, because the capacitors have or are about to give up the ghost. The capacitors that are in here are notorious for bursting, and that can make an incredible mess, which using chemicals to clean can make other problems occur or make existing problems worse. So we need more information. Let's get this unbuttoned and move into troubleshooting, identifying defective parts, capacitors, and move forward on this. Now that I've got this unbuttoned, I can do a full-on visual inspection. There are no burst capacitors, no burn components, nothing is discolored from heat. Also, foil runs are all pristine, intact. Well, lo and behold, I discovered this. What's wrong with this picture? I'll give you a hint. These are the same boards. They're each for the playback amplifier output.
One of these things is not like the other.
They're not the same. What I've discovered is that this capacitor here is a radial capacitor. On this other board, this one, a Frako, is original, and it is an axial capacitor. When you see stuff like this, what that usually tells me is that the previous repair person didn't have the right part, right capacitor to replace this with. This one isn't even seated on the board all the way. It's elevated. It's up on stilts. I mean, it came from like what, North Carolina on the Outer Banks? I mean, come on, why is this up on stilts? It's up on stilts because it's not the right capacitor. Now, okay, well, radial versus axial, all right, but electrically it's wrong too, because when you look at this particular board, this is a 1600 microfarad capacitor at 3 volts. 1600, 2200 at 16 volts. So it's like, all right, well, I really don't have even anything close to being right, but I can make it fit. Well, you know what? It doesn't really fit either, because when you plug this board into this deck, there's a knob right here and some electronic stuff behind here that it can't clear, so he actually put it in there at an angle. To me, that's a tell. Clearly this has been worked on before. And in my defense, I have worked on this before. When I got this deck a few years ago, the capstan motor wasn't seized up exactly, but it did have a lot of friction and resistance in it, so I took the motor out, tore it all down, cleaned it all out, re-lubricated it, put it back together, and it's been fine ever since. Also, the brake bands for these reel tables, all right? Well, solenoid here that releases the brake bands, they were broken, all right? So they had to be replaced. And then, right over here, this guide, this tape guide, was a roller bearing, so that had to be replaced. This predates me. With this knowledge moving forward, now I have to go through here and check everything that might have been touched. One good tell is this, okay? This is a panel that goes on the bottom, the very bottom of the deck, and all of these little openings here are for You're supposed to break through them, and you can make adjustments. You can adjust the bias and the bias, not the bias frequency so much, but the bias level, the bias trap, record levels, playback levels. All of that stuff is accessible through the bottom of the deck. None of them are broken out, okay? Which means that nobody's been poking through. Now, theoretically, somebody could have just taken this panel off and made those adjustments, but this, you get a good feeling by seeing that these have not been broken through. I'm prepared to go through this and make those repairs. Gonna do that, and in the meantime, keep my eye open for anything that doesn't look correct. They don't call it a sore thumb for nothing. When there's a sore thumb, then you need to take care of it, otherwise it gets infected. Now, that said, is why all of these are piled up over here. These are all the old capacitors. I'm not going to waste your time with video footage of that, but what I do want to share with you are some of the things that I'm aware of when it comes to replacing capacitors on this. Most of the capacitors in this chassis are fairly easy to replace. This board right here is waiting for delivery of capacitors 1600 at 3 volts. 1600 at 6 volts, couldn't get one of those right off the bat, you know, but what I did get was a 1500. This capacitor here has been replaced, did a pretty decent job. A couple of things that I did want to point out to you, and these are just time-saving tips. This first capacitor, which is the first one that I also worked on because I recognized that it was going to be a pain in the buttocks in order to get to, and that is this capacitor right back here, okay? Now, this capacitor is new, it's axial, okay? But getting to the back side of this board was going to be a problem because there's just no room to get in there. And there are 4 screws that hold this board in, okay? There is 1 screw right back in here, and then 2, and then 3 is right there, okay? The 4th screw is right back in there. And you can't even get a screwdriver in there with this still assembled the way it is. So do yourself a favor, leave breadcrumbs. This is just a sketch of that board that's in there. These 3 right back in here, orange, white, and green. Well, there's 6 connections right here. I believe these are going to be for the amplifier cards for speaker outputs. You can actually just power speakers with this. And those cards are in here. You're going to have to take these 6 wires off, those 3, and these 4 here, which go to the take-up reel motor. I highly recommend using a magnetic screwdriver because the screws are steel, and that way you don't risk dropping one down inside here somewhere and losing it. To get to all of this is going to require some homework. The reel motor. You're going to have to physically just remove the entire reel motor in order to get to that spot. These 3 screws will take this reel table off. You take that reel table off, there's this nut, and there is no spline for the shaft of the motor. The thing to be really, really cautious about is this brake band because it is really, really thin. I've seen quite a few of these decks where the brake bands are just broken, and that just comes from use or abuse. I'm loosening up this nut. Once I get this to where I can get it off with fingertip, it's going to have that washer on there. Then I recommend relaxing the brake and then just very gently sliding this straight out. Yeah, very gently. What happened just there is that the tape counter belt is also attached to this, so it sort of snagged as it fell out. 4 screws hold that motor in, right there, and right there. There is this brace back here, this little bracket right here. It's just like a little friction bracket. The cabinet is going to brush up against that and actually hold it, not only tight, but it'll sort of hold it into position as well, okay? So we'll just take both of these loose, this bracket is loose. The power cord is actually dressed a grand tier and it's wrapped and so forth, but that right there is as much movement as you need for this real motor to then just fall out right into your hand. Now at that point, you just pull those 4 loose, then you're going to remove this umbilical here with these 6 leads, then you can get to this topmost screw, the board will be loose, and you can just finesse that around and down so that you can get to the back side, the solder side of that board. I'll also point out that the actual circuit board is right here. This is a solenoid for the brakes. Tilt the board down a little bit just so that this edge right here will clear this solenoid. Once you get that cleared, then the board will pivot and you don't even have to take all these wires off. I will point out to you that in most cases, okay, the A77s that you end up working on, there is a red and yellow here and a red and yellow here. Didn't want to get them confused. It would have been fairly easy to tell them apart because this red and yellow here actually comes out of the wrap at this point. This red and yellow comes out of the wrap at the top up there. I marked them anyway. That way, when I look at my cheat sheet, I know which is which. It's like a heater core in your car, okay? They took the heater core off the shelf and built the car around it. So it's just like, you know, that can be a real challenge, but hopefully that will help you out. Now I'd like to point out another capacitor, which will have to be replaced, is this one right back here. Getting to that one is probably the next hardest to get to in here. That's because there is an added shield right here to protect all of the audio components that are going to be right here, because these 2 empty slots right there are where the playback amplifier cards are going to be plugged in. That is in no way a deal breaker, because that shield is only held in by 2 screws, one here and one here. You take those 2 screws out, set them aside, then that shield kind of thing is simply going to want to just fall out from underneath there. Once it's out of the way, you can get to the solder side of that relay board and replace that capacitor. On this board, these jacks for headphones and all of this, in order to get to the solder side of this motherboard, you're going to have to just almost totally disassemble the whole bottom third of the deck. But I'm going to make a suggestion that may be a bit unorthodox, but it's totally viable and not a deal breaker in my opinion. It's not a purist point of view, and I try to be a purist in most things, but in some cases, dismantling this to such a degree, you risk making it worse. You might break something else, and you have to be able to replace the capacitors. So this capacitor up here was just another one of those Frakos. I didn't get to the solder side in order to remove the old capacitor. I did install this new capacitor, and here's how I did that. This capacitor, cut it short to the capacitor body, and by virtue of that, I took the leads of that capacitor and made a little loop in the end, about 1/4 of an inch from the body of the capacitor. That little loop I used to wrap around the stub that was sticking up from the old capacitor on both ends, and then just soldered it to that lead. One thing you want to be mindful of is when you're doing that, you want to do it quickly. Make it a good solder joint, not a cold solder joint. I'd recommend put a hemostat down against the surface of the motherboard to draw the heat off of the soldering that you're doing above it. Okay, that will prevent heat from building up and desoldering the other side of that motherboard. And the same holds true for other capacitors on this motherboard. Just pop this circuit board out here. I'm using an actual radial capacitor. Could have used an axial. I didn't have any, but I had the right value in this particular case. Did the same thing right there. The truth is that if it works, it works. It got it back up and running in short order, which is what I accused somebody else of at the beginning of this particular segment. Maybe I learned something, okay? But nonetheless, we're real close to getting this back in. We get the capacitors in the mail, and I'm going to put those in, and we're going to fire this puppy up. Now, before we can actually power this deck on with it outside of the cabinet, I need to point out that they had the forethought to put an interlock in here so when you pull the cabinet off, the chassis cannot be energized. Each pin goes in far enough to make connection to another contact inside this, and there are two of them, one for each leg of power. It's basically a single pole, single throw switch. This is riveted in place, for crying out loud. So I mean, you know, take this out, you're gonna booger the cabinet. I don't want to do any of that to this cabinet. What I do have is a couple of Revox adapter pins, which is just basically a piece of, I don't know, what is that, 8 gauge? What we do is just take this and gently insert that into this mechanism till it bottoms out. It's got to be bare copper wire. I mean, it's got to be able to make contact, right? So now you can put power into this and be able to run all of your tests and so forth. Be careful. You might want to cover that up with electrical tape because those are going to be hot. You know, there's going to be AC juice on there. Now, while I've got a few minutes, I'm going to go ahead and just replace these Frako capacitors that are on the speaker amplifier cards. Were purchased separately. All right, they did not actually come with the deck. So I don't know that they work, but I'm going to go ahead and recap them, install them, and then at some point we're going to run a tape through this thing, test the speaker outputs. Let's get started on these caps. Obviously, these are going to be powered with a bipolar power supply, full wave bridge rectifier, bipolar cap. I've already marked the polarities. They're in series, so I've marked negative sign here, positive sign here. Polarity is critical with electrolytic capacitors. These capacitors have an applied adhesive, which is going to be right down in here. Might even help to sort of just work this back and forth a little bit. Try not to run into any of the other components that may be nearby. If I can sort of just stress this a little bit and see if these solder leads are moving, then I know those are loose and I'm not actually fighting it. So yeah, they're loose. Took the coating right off of that capacitor right there. Okay, negative, positive. This is 2200 microfarad, okay? 2500, almost 26. But it's dropping. Not really that far off. Again, just sort of working that loose. This one didn't have near as much adhesive on it. Again, 2500. So, fortunately, there's no foil runs on this side of the board, so I don't have to be terribly careful, but just trying to only go as deep as the adhesive is. You're always going to feel some of that remaining, but it's really not a concern. Let's just check one of these. 2200. These are at 40 volts. The old ones were at 25. 2240. That's a pretty good cap. I like to sort of get these in here mounted so that the values are actually on top. So at a glance, you can just see what you're working with. Negative lead, like that. All right, that is much prettier. Just looks right. I'm only going to do one lead until I get the second capacitor in there because they share a solder joint. So I'm going to do this lead, which will hold the capacitor in place just long enough for me to get the next capacitor in there. Then I'll just solder both leads at the same time. One thing I like to do when I'm actually trimming off the excess lead is I don't like to get it right down there on top of the solder joint. I like to just have a little bit above. The best way to do that with these side cutters is to simply push the side cutter down, let the tip of the side cutters touch the board, which is going to give me just enough above that capacitor. You want to have enough to be able to, one, put a probe on there in order to take a reading, or have enough to work with in case you had to remove that capacitor again. So now I can stretch this back straight, leaving room for the next capacitor lead to come through there. Assuming that the holes are going to be the same, and assuming is a dangerous thing, but I'm going to go ahead and just do these leads at the same angle, distance that I did the last one. And as it turns out, the holes are not the same distance as the last one. So straighten this out again. The whole idea is to have less horizontal distance before the bend. Bada boom, bada bing. I'm gonna go ahead and bend these leads to hold that capacitor tight to the board. The amplifier cards are going to be inserted into these slots here. One for the left channel, one for the right channel. The cards themselves are going to be held into position with a little bracket. That bracket is going to be held behind one of these two screws right here. This screw here, I haven't touched it yet. The paint has not been broken, whereas the paint here is broken because I just broke that with a screwdriver. Of course, the card never having been in here is probably going to have to just finesse these cables that are in here and so forth. All right, but that is seated into the card socket and just eyeballing this here. Now, the trick is to get the screw in there, and there's just not a lot of room to work with in there. Okay. Okay, and now the capacitors have arrived. So let's just get right into this real quick, you know, with the obvious acknowledgement that this may not even make it to the video. Now, let's get that chassis up on the bench. Oh, there is something I want to show you too, because it nearly stumped me. Thought I'd done something wrong, and as it turns out, when you study the schematic diagram, the voltage regulators don't engage until the voltage that's going into the regulator reaches a certain threshold, and I'm going to show that to you. There's a lot of power supplies in this. I mean, you think of a power supply just being one, but there are multiple secondary windings coming off of the master transformer. But the one in particular that I want to show you is the one that had the issue with the bad capacitor, that one that's like buried deep inside here. So I know where I'm going when I'm actually connecting these leads onto here. I've got this in DC mode at 10 volts per division. Power supply that I'm actually connected to right now is a 21 volt supply. It's supposed to be pure DC, regulated at 21 volts. Okay, and that is exactly what it does once you get there. Okay, so I'm turning this on. Bench supply is on as I gradually raise the voltage going in. That's 40 volts going in, 50. 60, and I'm beginning to see some ripple riding on that. So I'm going to pause at 70 volts supply voltage. I'm also going to reduce the resolution on the scope to 0.2 volts per division. This is what I saw that kind of rattled my cage. Just put a new capacitor in there and I've still got ripple. Where is that coming from? Is it a shorted diode and a bridge rectifier? Turns out that because I haven't really fed it full voltage yet, going in, it wants to see, the tap on this is right now at 130 volts. Now I can probably set this to 110, but it's at 130 volts. It wants to see 130 volts in order to provide the necessary DC for the voltage regulators. They haven't loaded up the power supply yet. The voltage regulators are saying, what, you woke me up for this? So I'm going to continue to raise the input voltage from 70, now 85, and then as we approach 90, the regulators take over, they load up that power supply, and the ripple is gone. Okay, I'm going to go to DC mode. I'm going to switch this first of all to 10 volts per division. I've got 21 volts coming out of that supply with 100 volts going in. There's 110, there's 120. Okay, obviously no change because everybody's happy. So I wanted to show that to you because if you end up having to work on one of these, you probably want to know that because you don't want to start chasing your tail or a wild goose chase or something like that because you see ripple and you say, oh, what else is wrong? Make sure that you're just gradually increasing voltage until you get to the technical supply voltage that the deck wants to see. Moving along, I can point out to you that power lamp is working, but I just noticed something else. There is another lamp way back over in here. It's for that tape end sensor right over here. That's supposed to be on too, and it's not. And there's a good possibility that that burned out. It's just a bulb. So we're going to spin this around and take a look at what's going on there. Just one thing after another. It's a bulb that just pushes in. It's just got a couple of prongs on there. Just put a piece of heat shrink on there. Heat shrink on there. And since it's heat shrink, we will heat shrink it. So now let's see if we can't get on this thing, and there we go. Better safe than sorry. Now let's just go ahead and check this up real quick. And that's open. Just to confirm. And the meter says nada. So here we go. This, you don't need the tool to actually put it back in there. It'll just slide in on its own. Okay, and boom. I'm saving the dead ones. I'm gonna make a bracelet. So this is what we used to call the smoke test. Here we go. Everything seems to be fine there. So what I've got here is a tape that I made on this deck, oh, I don't know, a month ago, 2 months maybe. Okay, it's 4-track mono, but it will effectively demonstrate one channel or the other. We'll just get this all fired up. Okay, and there's that. It's 3 3/4 inches per second, so I'm going to go to 3 3/4. And technically, these would be large reels, but they're plastic, so they're not heavy 10-inch reels, 10.5-inch reels. So I'm going to go to the less torque on the tape. So let's see how this behaves. Okay, that's track 1. Here's 2. Track 1. Track 2. Okay, so that much works. In stereo, I would have both tracks playing different songs at the same time, and although I really can do that, I'm not going to do that to you. So now it's time to just re-rack this tape, get this all buttoned up, and put it back into service. Thank you very much for watching. We'd like to have your comments. I just would like to hear from you. If maybe you've got an idea, or maybe I missed something. Okay, not perfect. Can do just about anything, but I make mistakes. I'd like to know if you think that I did, and we can talk about it. All right. If this has been helpful to you, great. I hope you'll come back and watch some more of our videos as we get them posted. If you subscribe, then you will actually get a notification. But you know all that, all right? And if you just want to say, hey, you know what? It was interesting, appreciate it, give me a bell and thumbs up, and that'll be all kinds of cool. All right? Appreciate you guys. Hope to see you soon. Take care.